What's up everyone, Jessica Dean here. Today's video is coming at you by request. I've received a lot of positive feedback from those of you who are enjoying my Kubernetes videos, and thank you so much for that. But what about those of us who maybe are brand new to this? Maybe we're not quite sure what a container is, or maybe we've never touched Docker. Maybe we don't know what Docker is. This video is for you. So first question, what is a container? A container is not actually a real thing. Instead, it's an application delivery mechanism with process isolation. So what does that mean? It means that a container's sole goal is to deliver an application as we define it to our end users and to our customers. And ideally, it's going to be adding something as a value, because as engineers, we want to deliver valuable things, right? Now, if we think of it in terms of virtualization, where we had physical hardware virtualization supported by a hypervisor, whether that's Windows Server Hyper-V or VMware ESX, this answers the second question, because in terms of containers, that's where Docker comes in. Docker enables us to, in essence, virtualize the operating system or the kernel. And so now this allows us to create very, very small containers or images that we need to deliver that valuable application. We have just the kernel and any application dependencies right alongside it in that delivery mechanism. So what problems does this solve, and why do we care? First off, who has heard the "it works on my machine"? Probably everyone, right? We no longer have to worry about that because the image or the container is now portable. It now is immutable. It's now versatile, and I don't have to worry about it being changed, and I don't have to worry about it not working. It's just one packaged bundle of joy that's delivering that valuable application. An easier and more delicious way of thinking of a container is comparing it to a waffle. Now, I don't know about you, but I don't enjoy eating waffles plain. I like to add things to it. So if the waffle is a delivery mechanism and I add valuable things on top of it, like blueberries and strawberries and syrup and butter and whatever else, that waffle is delivering that value or that happiness to my stomach or life. I can also compare it to a whiskey glass, because I don't like my whiskey glasses empty. Instead, I like to add things to it, right? Whiskey. And so now that whiskey glass is delivering value. So really, a container is a waffle or a whiskey glass. I don't know. Let's hang out, let's have some fun, let's learn some stuff, and maybe at the end, we'll eat a waffle and drink a glass of whiskey. Who knows? All right, so the first place to get started is going to be to set up Docker Desktop on our system. The instructions are going to be a little different depending on if you're using Mac or Windows or Linux, and I'll have links to everything down below. But for now, since I'm on a Mac, I'm simply going to click Download for Mac. This is going to open a new tab. I'm actually taking a Docker Hub where I can download Docker Desktop for Mac. All I have to do is click this button on the right. But before I do, I want to focus on the address bar, and specifically right here in the address bar where it says Docker CE. CE stands for Community Edition. Now this can be a little confusing when you're just getting started, because you might see Docker CE as an offering, but you might also see Docker EE. Docker EE stands for Enterprise Edition. The CE is open source, readily available, easy to use, easy to get started. EE is the commercially available and distributed offering for Docker. It has premium tiers and even comes with Docker support. So today's video is going to focus specifically on Docker CE. I'm simply going to click Get Docker, and this is going to open another tab where I can choose to save the Docker downloadable image to my desktop or anywhere else that's easily accessible. I already have Docker saved on my desktop, so we're going to go ahead and just use that. Do note that it is about 675 megabytes. So if you have fiber, it'll go pretty quickly. If you're on hotel Wi-Fi, wait a minute, no one's on hotel Wi-Fi. So we already have it downloaded, as I said. So I'm simply going to launch the Docker installation image file. And on Mac, all it has to do is really open the file, and then I can drag the application over into my applications folder. And we can see that right here. I'm just going to click Docker and drag it on over. And it's going to start installing or unpacking. Once it's been installed into the applications folder, or copied as Mac OS puts it, I can then double click on it to launch the application itself, which I'm going to do right now. So we'll go in here and I'll just click Docker. Now, this is going to start actually setting up Docker with everything that's needed. It's going to ask us two things, one of which I think is a little silly. The second thing we'll talk about more in depth in a future video, but I just opened it. This is the first thing you might see, which again, I said is a little silly. It says Docker is an app downloaded from the internet. Are you sure you want to open it? My first question is, what application these days is not downloadable from the internet, right? So I'm just going to click open because obviously we want to use Docker. The second pop-up is Docker needs privileged access. It needs access because it's also going to deal with some networking components, and that'll tie into future videos with links and Docker stack and all this fun stuff we're going to learn. So we're just going to set up Docker the appropriate way right now and click OK. Because it needs privileged access, we're going to need to enter in our password. So I'll simply make sure we do that. And now Docker's going to start up, right? It's starting to load. You might even see this little Docker desktop is starting pop-up window. It gives you some commands that you can get started with running: Docker info, Docker PS, Docker version. We can certainly test those out. You might also see right beneath this where it says Docker Desktop Community. This is where it's asking for a Docker ID or password. If you don't have a Docker ID, you can create one at hub.docker.com. And so I already have hub.docker.com up. And we'll close this little pop-up window out. And it's free and easy to get started with Docker Hub. You would simply choose your preferred Docker ID, your email address, and your password, and you click sign up. Now you might wonder why you would want Docker Hub. And we're going to focus on Docker Hub in a future video, but it's mainly going to help us when we want to have our own registry or repository, a place where we can store the images that we create that we want to run in containers. It's going to be a place to safely store those, and they'll be publicly available. In fact, we can see other Docker Hub images by simply going to hub.docker.com and typing explore. And that's going to take us over to where we can see all the various container images that are available. In fact, there's over 3.3 million images. You might also see Docker Certified, which comes coupled with Verified Publisher. Docker Certified means that Docker themselves have verified this image. It is guaranteed to be by the publisher or the vendor, which means it should be a pretty secure image. There are some instances where security exploits and vulnerabilities have been found, but for the most part, those images should be trusted. We can see we have images by Oracle and Java and MySQL, IBM, Couchbase. Scrolling further down, we have Alpine images and Ubuntu images and Node images, right? This is where we're doing that. We're planning for that base. We're planning for the base waffle where we need to know the bare minimum of what's needed for our application. And we'll talk about, again, using this a little bit more in a future video. But for now, let's go ahead and search for an image itself. Let's go ahead and get started. And real quick before I do a search, notice here, this is where you see Docker EE and CE. So that's one of the reasons I wanted to review the differences. So now let's go search for our first image, which is going to be hello world. You can see right when I start typing hello, it starts suggesting which image I might be looking for. Obviously I want hello world, and it's nice because it also tells me that this is verified content. So we're going to select that, and we can see that it's a Docker official image. We also can see little tags. Is this a Linux container, a Windows container? Will it run on ARM or IBM? Or what are tags that have to deal with this specific image? Since we're just, again, getting started, you can also see, by the way, this is 1 billion plus downloads, which is pretty nifty. We can run this image or use it a few different ways. First, we could do Docker pull hello world. And when we're running this image or when we're pulling it down, we're just running whatever this hello world application is, which the traditional hello world is I print something to the screen or I echo hello world back to me, right? So we can already kind of assume that whatever we run is going to echo or print some sort of text to the screen. So let's switch over to a terminal here. And the first thing is let's try to use Docker. To do that, I'm just going to type Docker. And I can see all the different commands that I have available through the use of Docker CLI. I can do some of the commands that was suggested to me, like Docker PS, where I could see any processes or containers that are currently running. I could do docker ps-a for -all. Now, all is going to come in handy because just because a container isn't running doesn't mean it doesn't exist on your system. And we'll see that in just a short minute. I can also do docker images, so I can see any images that I pulled it from and from which repository with which tag, what's the image ID, when was it created, and even the size. Maybe I want to do Docker version, and I want to see which version of Docker I'm currently running. You can see I'm running the Docker Community Edition engine. So let me go ahead and clear now, and we will run our Hello World image. Now we're able to run the Hello World image because if the image doesn't exist, it's going to pull that image automatically. So we don't have to do docker pull Hello World and then docker run. We can just do one command. And so you can see right here, it says it's unable to find Hello World latest. The latest after this tag is, or the latest after the colon is what's called the tag. This is how I can incrementally set whatever my image is. I can version control it. The section right here to the left of the colon is the name of the image itself. So since it wasn't able to find it, it went and pulled it from the general Docker Hub library Hello World, right? We went and just looked at that image right now. I can see the checksum right here that's printed out in the digest, and everything after this little space, this text right here, that is our printout. That is our echo to confirm here's all Hello World. Rather than saying just Hello World and being boring, it says hello from Docker. This message you can read on the screen, but this shows that it's working properly. Now let's go try some of the commands we just used where I want to see what running processes or containers I have. If I do docker ps, we might be surprised to see that the container isn't running because the container's only job, the only application delivery it was doing was printing our Hello World. So instead, if I do docker ps-a, I now can see that same container, which is closed out. It took maybe about a minute, or what it was created a minute ago, pardon me, and it exited about a minute ago, meaning it only took a few seconds really to start and run up. I can see important information like the container ID, which because of my terminal spacing lines up with container ID because of the spacing on the left-hand side here. And this indented names lines up with the indented flamboyant Schwartz. So you might be wondering why flamboyant Schwartz is on the screen. Well, when I did docker run, I didn't name it anything. So Docker's going to give me a cute little fun name to get started with. If I wanted to name it something smart, I could do -- name equals whatever that value is. So I could say hello YouTube and space and hit enter. Now that runs that same container. We know that we still don't have it running, right? Its job is only to echo and talk to us. But if I do docker ps-a, now I see both hello YouTube, which we just created with the name, and flamboyant Schwartz. So this is great. We're, believe it or not, already getting started. We now have images on our system. So I can do images, and here's our Hello World image. We can see our tag, we can see our image ID, and this image was last updated 15 months ago. It's also a whopping less than 2 kilobytes. So what happens next? Let's try to actually run an application. And for those of us that maybe aren't super comfortable in the terminal or in command line, let's try to do something that'll help us visualize what's running. To do that, I like to use something called Portainer. And Portainer is probably one of the easiest ways to visualize and have visibility into what's going on within Docker, either in a local system or remote. Now, the main command we're going to be running is the one I have highlighted, and we'll take a look at that in depth. But there are different commands depending on if you're using a Linux host or a Nix host. I can run the same command on my Mac, or if you're running it on a Windows host. Mainly how we mount the socket, the access to the Docker engine. We'll talk about that shortly. So let's flip back over to our terminal. And again, there'll be links to all that. And I'm just going to do docker volume. And first, I want to list any volumes. Now you might be wondering, why do I care about volumes? By default, containers are stateless, meaning they don't persist any kind of data. There isn't any kind of persistent storage. Once the container exits, since everything that happens inside the container itself is a read-only, anything inside the image or what we define in our container is read-only, when we run our containers where read-write actually happens. So anything that's happening in read-write, if it's a stateless system, doesn't get saved. We need to create a volume and attach it if we want to make it a stateful application. So to do that, we're going to do Docker volume, create, and I'm going to name my volume. In this instance, I'm going to call it Portainer data because it's going to store my data for my Portainer application. Now, next, I want to actually run Portainer itself. So to do that, we're going to do Docker run again, only this time I'm going to run a different command. And let's break this down. Let's break down what this command is doing. First off, we see -d. -d means it's detached. I'm no longer going to see that print or the echo or any logs of the container. Instead, I'm just going to see the container ID because it's going to run silently in the background. -p, which we see twice here, is going to port forward the port in the container to a port that's accessible on our system. It's going to make our systems talk to the container. So on the right-hand side of this little colon, that's the port in the container. The left-hand side of the colon is the port on your system. So you're just routing the port on your system to the port in the container. Now, I know because I'm familiar with Portainer that this is the port that our application is listening on, and this is the port where our application is going to be accessible. So we'll see that in just a few moments. The next part we've already talked about because we know how to name our application or our container. This next flag is restart, where I'm going to restart always. In the event that this fails or has a memory dump, the container is going to try to restart. Now, right after that, we have -v. -v stands for volume. So we already created our volume to make our application stateful, but we also need to use -v to attach our Docker engine on our system to the Docker engine component within our container itself. So just like how ports work, the left-hand side is our system, and the right-hand side of the colon is going to be the container itself. So we're just mounting access so that our application can talk to our Docker engine. The final -v is slightly getting cut off by the edge of my screen resolution, but it's -v space P, zoom out, and then the remaining part of that is Portainer data. That's taking the volume that we just created right here, and we're mounting it to /data in the container. Remember, right is container, left side is local system. The final part is the name of the image that we want to run. So let's hit enter. And while it's downloading, because we've never run this before, it doesn't have the image. It's going to pull it, it's going to run it. While it's doing that, which it's done, let's flip back over here. And I do just want to show you in Docker Hub what image we just downloaded. So if I go to Portainer, we can search. Here is the Portainer image, and it was distributed by Portainer. There's over 10 million downloads of it. It'll run on Linux, Windows, ARM. You can see all the tags. And if we drill down into that, it even shows us exactly what it's supposed to do, which is making Docker management easy. And there's a great link where we can go and learn more. It's just going to give us a UI for everything with Docker. So let's go back over here, and you could see it ran in a detached state, meaning all I got was this long series of letters and numbers. That's my container ID itself. So now if I do Docker PS, I don't even have to do -a for all. I can see the container ID, which lines up with the first several digits of this full container ID. This is a shortened number scheme. And then I also have the image, which again lines up with this top higher level image table name. And then I have names, which lines up with the name of the container. I can see the command that was run. I can see when it was created, and I can see that it's forwarding ports. So now we can actually test our application. And by the way, we've been working for just a few minutes, and we already have Docker installed, and we have just run our very first application inside a container, and it's going to help us do something right now. So I can go to localhost, only this time I want to make sure I specify port 9000. Now, because I've never used Portainer before, I have never set up an account or a username or a password. So I'm going to go ahead and make a super secret password. It's obviously not going to be password, right? We believe in security. But enter password to create your user account. Now, the next thing you want to do is you want to choose which Docker environment you want to manage. This is really neat because you can manage something that's remote. You could manage another Portainer agent, or you can even connect to Microsoft Azure ACI, which is kind of like Docker run in the cloud. It's Azure Container Instances, and I could run any image I want with one command within Azure. So we'll do another future video on how to get started with ACI. But for now, we just want to see what's going on locally in our environment. So we'll click local. And this is where I was saying that we want to make sure that we run different commands, whether it's Linux or Nix-based systems versus Windows. We just have to mount that access to the Docker engine accordingly. So in a Nix-based system, we mount the docker.sock. In the Windows-based system, we mount pipe docker_engine. So now we're just going to hit connect. And right there, we now can visualize and see what Docker instances we have access to. So here's my local instance. I can drill down into this and I have a nice, neat little dashboard. I can see the var run docker sock, which means it's communicating to my local system. I can see that I have 3 containers, but only 1 is running and 2 is stopped. Remember, the first 2 was Hello World. I can see the images that I have downloaded, which is Hello World and Portainer. I can see the volume I created. And networks, again, will focus in on a future video. So for now, let's drill down into containers. And you can see the name of Hello YouTube, which again is in a stop state. I can see the first image that was run in a container, the Hello World, Flamboyant Schwartz. But I can also see this application right here that we're currently running, Portainer. I can even scroll over and see the ports that it's accessible at. I can see who owns this container. I can drill down into it and see this full container ID. In fact, let's go back over to our terminal here, and I'm just going to copy this short container ID, go back over to our browser, and we're just going to do find here real quick. And you can see there's our short container ID, and it's just the prefix for our full one. So we know that we're seeing what's actually running in our system itself. Now let's go back up to dashboard. And we can drill down and now see images. And we can see again the checksum, we can see the tags, we can see the size. The same things that we were visualizing from CLI, we now have an actual dashboard and insight into this. If we go back to our dashboard, we can also see our volume. And that's the volume that we have connected to the Portainer data volume within our container itself. We can see that we're using a local driver because we're not doing anything with NFS or SMB. We're just using local storage to persist our data. Now, persist our data, again, means that we're making this stateful. So let's go ahead and test that out. I'm going to go back over here, and instead of doing any kind of view commands, which I mean docker ps or docker ps-a, let's clear, and now let's do docker stop. And we're going to stop the running container. We can verify that by, again, looking at our processes. It's stopped, so that's great. Let's go back to our browser and refresh. And we no longer have access to our application because we stopped that container, right? Nothing's now listening on port 9000 or is accessible on port 9000. So now we'll go back up to docker stop, but we're going to change it to start. We'll say start Portainer. Now if I do docker ps, the container is started. I can see that. It's been up for 3 seconds. So we'll go back over here, refresh, and just like that, we no longer have to create a new user account. Now I can enter a username. So I want to enter admin and my super secret password, and I don't have to reconfigure remote versus local versus whatever other option. I have that persistent, stateful application ready to go. So that's the first part, where now we have learned how to run images, even images we don't have on our system. We now have a nice little dashboard for what's happening and where. In fact, one more thing while I have you on the line is I want to show you on our running container, we can even drill down and click logs, and I can see the actual logs of what's happening in the container itself. When it had to create an administrator account, when the templates were already registered, so it didn't have to start the template check. I can see any errors that are happening, where it's listening or where it's being started from. I get direct access, which is one of the reasons how come I love this visualization. All right, so let's recap. First, we learned how to install Docker. We learned what a container is, and we even learned some Docker commands that we can use. We wrapped all of this up by running our very own Docker management UI using Portainer, where we weren't concerned about what dependencies Portainer needed or what language Portainer was even written in, because everything got bundled up in that application delivery mechanism known as a container. Next week, we're going to go even deeper. We're going to create our own image. We're going to write our own Docker file completely from scratch, and we're going to work more with application delivery mechanisms. But for now, I'm going to focus on eating this adorable delivery mechanism, which is BB-8. I have added my butter and my syrup, and I can't wait to eat it. But I also did not forget about the other delivery mechanism, which is this whiskey glass here, and it's delivering an old-fashioned complete with cherries. So don't forget to subscribe to my channel if this video helped you. Please also share, and I will see you next week. Cheers, y'all. Oh. Yep, that's definitely valuable. Yep, it's good stuff.